Um, Previously, this was something I would teach at the end of the rowing class that would used to be taught every month, but now we've kind of spun it out into its own thing. Um, so today, what I hope to give you is a basic practical overview of what the tides are, how to find out when and where they happen, and how they affect you as a swimmer and a rower. Because I think swimmers and rowers kind of have different priorities when they get out into the water. And we'll touch on the basic, like what causes the tides, but I'm not going to go too deep. If you do want to learn more, I'll be sharing this presentation, the link to it, so you can maybe study the diagrams a little bit closer. And there is a very in-depth and detailed document that's being compiled right now that will have lots of information for you if you want that. So, what are the tides? Basically, when we talk about the tides, we're talking about the cyclical rise and fall of sea levels caused by the gravitational relationship between the sun, the earth, and the moon. These two diagrams basically show, these three objects, and the biggest component of this relationship in terms of the tides is actually the relationship between the Earth and the Moon. The sun does affect, the gravitational pull of the sun does affect the tides, but not as much as the moon does, and our kind of orbit with it. This relationship is very stable and it's incredibly reliable, so we can actually predict the tides very far into the future, as well as figure out when the tides happened in the past, just working backwards. So when we talk about tide information, we're using these relationships to predict the information that we use. Where do tides occur? Basically everywhere, but for our purposes, they're the most noticeable on the world oceans and kind of connected tributaries like estuaries, river deltas, etc. Just as a side note, like large fresh bodies of fresh water, like the Great Lakes, do experience tides, but they're so small that they're really quite negligible, and so we don't really talk about those bodies of waters as tidal, experiencing tides in the same way as the ocean does. And so for us, the bodies of water we're concerned with are the Pacific Ocean and San Francisco Bay. So I'm going to start with a bit of terminology. Tide is this kind of big word that means a lot of different things, but generally speaking, when we're talking about tides, we're talking about the height of the water. So the general height of the surface of the water of the bay or the ocean. And as that changes throughout the cycle, as it goes up and down, there's an associated movement of that water, which we call current. And that has a speed and direction component. And when we talk about current, we're going to talk about, we're going to use these two terms, flood and ebb, which you've probably heard before. A flood current flows into the bay from the Pacific Ocean, raising the height of the surface of the bay. And then an ebb current flows out of the bay to the Pacific Ocean, lowering the height of the surface. And so I've got some diagrams here just illustrating that. So as you can see, during a flood tide, water comes into the Pacific, in from the Pacific through the Golden Gate. And one thing you want to notice is that from the perspective of the club, that movement of water is in an east-west direction. Yet once you get past, around the corner, closer, as the bay kind of splits off into two different directions, the current splits as well. And so in other parts of the bay, they would experience more of a north-south movement of the water. And then during an ebb, the water turns around and kind of heads back out towards the Pacific. So that's what happens in the bay. Let's take a look, a kind of a zoomed in look at what happens in Aquatic Park Cove. One thing we kind of that helps define what is happening in the cove is to understand eddy currents. I think we've all kind of witnessed, maybe in streams or rivers that we've been to, water, there's the main flow, and then as that main flow flows around different objects like rocks or boulders, we can see the water kind of changing and swirling around rocks and trees that may be in the main flow of water. And the same can be said or can be observed in the bay as the main current flows around piers, around seawalls, docks, and that kind of thing. So this is an aerial, a satellite image of Aquatic Park. Here's the club. Here's Muni Pier. And as you can see, during a flood, as water is moving in from the Pacific, flowing into the bay, there's the main flow out here. And you know, there are all these objects that the current is flowing around, and again, it's creating all these different microcurrents that you kind of need to be aware of as it's, you know, if you want to swim, or even if you just want to row in the cove, if you're just starting out. One of the biggest, I think 2 points that create the biggest kind of variations or maybe unexpected current microcurrents would be the gap here called Farnsworth Gap, I believe. Underneath Muni Pier is a seawall. And so most of the current that hits the seawall goes around it. But then there's some that enters through here, which can create an additional push if you don't understand that that's what's happening right there. At the opening, you've got current that's going around this seawall, but then you have some that's running into it and then turning around and kind of being pushed into the cove. And so basically the thing to note that although the general direction is in this west to east direction, there are microcurrents that can sometimes change the direction and cause an unexpected condition. Same for an ebb, right? You have most of the water, most of the flow out here is flowing east to west. But there are, you know, unexpected conditions, like at the opening, you know, there's a ton of water flowing out here. And because this water is moving faster, low pressure situation, high pressure situation, water is kind of getting pulled out of the cove. And so you have an unexpected kind of micro west to east that then kind of pulls you out of the opening. And same around Farnsworth Gap, it acts as a little funnel, so you can kind of, as you're swimming past the goalposts, you might encounter an unexpected push towards Muni Pier if you're not expecting that. So basically, to recap this last section in terms of how the tides work. During a flood, water flows into the bay from the Pacific. It raises the height of the water. And from this perspective of the club, the resulting current is from west to east. During an ebb, all that turns around, literally. Water empties out of the bay to the Pacific. It lowers the height of the water. And from the perspective of the club, the current is moving from east to west. And as far as the cove is concerned, and other parts and other areas along the shoreline, eddy currents will form around objects that interfere with that main flow and cause microcurrents that sometimes either magnify the current or sometimes completely negate the primary current event and can sometimes push you backwards in a way that weren't expecting. So how do you find out when it's flooding or when it's ebbing? Well, there are two places where this information is published. There are tide charts, which is a graphical representation of what's happening with the tides over the course of a day, and there are tide and current tables, which is the same information but printed as a table, like a spreadsheet. So let's talk about tide charts and how to read them. So this is the tide chart for San Francisco Bay. This is March 2nd, sometime last week. And this data is for Alcatraz Island. It's the closest kind of measuring point to the club, and so it's the information that's going to be the most relevant when you're looking for tide information. So on the left over here, you can see this is the height of the water. And then down here, this is the increments over the course of a day. So I've plotted it in a 24-hour period. One thing you'll notice about this graph is that there are 2 peaks and 2 troughs. So here, obviously, this is the first high tide of the day, and the first low tide, second high tide, and the second low tide. That's very typical of San Francisco Bay. There are 2 high tides, 2 low tides during the course of a tidal cycle. And further, one of the high tides is going to be higher than the other one, and one of the low tides is going to be lower than the other. This phenomenon is what we refer to as mixed semi-diurnal, which I've defined down here. There are other types of tides. So if we experience mixed semi-diurnal, if the 2 high tides that occur during the day were roughly the same height and the 2 low tides were roughly the same height, we would call that semi-diurnal. Most of the east coast of the United States experiences semi-diurnal tides. And if a coastal area experiences only 1 high tide and 1 low tide during a tidal cycle, that would be called diurnal. And in North America, that mainly happens in the Gulf Coast. I've linked in the presentation notes to a page on NOAA's website that kind of shows the global, like what kind of tides are experienced around the globe, because geography kind of determines what kind of tides an area experiences. Actually, let's keep going with how to read a tide table. So that was a tide graph, right? So you can find the day, plot it for the day, and you'll see when high tide or low tide is happening, how high it's going to be and what time. How to read a tide table. So this one's a little bit trickier. I'm going to go over some terminology that's going to be important. The tide tables plot what are called tide events. Basically, it's a moment during the tide cycle when a maximum, a minimum, or a change is occurring. So we'll kind of go in order of the tide cycle. Max flood is a point during a flood when the current is flowing the fastest. So when the tides are changing, the speed of the current accelerates to a point and then decelerates to, let's say, to high tide, right? And then as it turns around and goes down, it accelerates to a point, slows down, bottoms out, and then turns around. So you can think of it kind of like a pendulum swing. So max flood is the point during a flood when the current is flowing fastest. High tide is the highest the surface of the water of the bay will rise at the end of a particular flood. Slack is the period in between a flood and an ebb, or an ebb and a flood, when the current is changing direction. Max ebb is the opposite. the point during an ebb when the current is flowing fastest. And then low tide is the lowest the surface of the bay will fall at the end of a particular ebb. So this is the cycle, right? It starts to flood, speeds up to a point, slows down, hits high tide. Then we go to slack, water turns around, speeds up as it's exiting, slows down, hit low tide, turns around, and we go up and down like that. So how to read this tide book. You've probably seen these around the club if you've been around for a while. The club has these books published every year, and I think we have enough printed for everybody. But you can find this information printed online as well, and it's printed in the same format. But at least in the book, on the left side, you have the tides printed, right? So the heights of the water when they occur. And on the opposite side, the currents. And those tide events I just talked about, or some of the tide events I just talked about, and when they happen. So let's start with the left side, the tides. At the top of the page, you have the month and the year, and where this information is taken from. What point in the bay is it taken from? And that's kind of important to know. I mean, I'll talk later about tide events happen at different times across the bay, and I'll talk about that a little bit later. But for now, note that if we want to know what's happening at the water closest to the club, you want to look at the tides at Alcatraz Island. Moving down, the information is written across for each day. We can start, let's just say today, Sunday, March 14th. The first tide event happened at 12:28 a.m. It was high tide, and it was 5.3 feet. The next tide event for today was at 7:09 a.m. and it was at 1.2 feet. So basically between 12:30 a.m. to 7 a.m., 4.1 feet of water moved out of the bay, right? We went from high to low, moving east to west, emptying. It's really important to know the difference in the height of the water because when we look at currents, speed is important to know, but definitely you want to know how much water is moving, because sometimes it's like, if you look at here Thursday, March 4th, it was a height of 6 feet down to almost zero. I mean, 6 feet of water is a lot of water. And so you kind of want to consider what kind of conditions are you swimming in or rowing in? Like how much mass are you swimming against or rowing against? One thing to note, you'll see some of these numbers are bolded. I believe numbers above 6 feet, tides above 6 feet are bolded, 6 feet and higher are bolded, and then below zero are bolded as well. Just something to note. All right, turning to the other side of the spread, we have currents. So same thing at the top. You have the month, the year, and where the data is being recorded from. Same thing, the information for each day is read across as a kind of timeline. So again, today, the first current event, was this morning at 12:42 a.m. slack. And then the next current event was a maximum current event. So at 4:36 a.m., the ebb reached a maximum speed 2 knots. And this little E here tells us it's an ebb. If you're curious, speed in nautical areas is measured in knots, which is 1 nautical mile per hour. A nautical mile is slightly longer than a statute mile. So that's just something to keep in mind. And as we keep moving across the table, we'll see the next current event that happened after that max ebb was slack at 8:12 a.m. And then we would just keep reading across, reading across, reading across. So where can you find this tide charts and tables? Tide charts and tables can actually be really, you can actually find that information pretty easily. If you just type tide charts, SF Bay, you'll find that stuff is printed everywhere. I think a lot of fishermen use it, so it's pretty widely available. Currents, I have actually found it kind of trickier to find that information. Again, we have it printed every year in this little book, which is where I got, today's spread. But if you're at the club for a swim these days, or hopefully sometime soon, you can pick one up. Before I move on, does anybody have any questions on like the tides generally, how they move? And I just kind of breeze through how to read the tide tables and the tide chart. But before we keep going, does anybody have any questions? And you're all muted right now, so if you want to ask a question, go ahead and unmute yourself. All good? All right, let's keep going. Okay, so what do you do with this information? Well, let's plan your swim. So let's say I wanted to swim at 3:30 p.m. Monday, March 1st, 2021. Well, I would check the tide book. Look generally around where I want to go swimming. And times are printed in a 24-hour clock. So you might need to learn how to read a 24-hour clock, but it's not too hard. And you notice, okay, high tide was at 1:03, and low tide's at 7, so that means it's ebbing right now. The height of the water is going lower. I noticed that max ebb is at 4:36. So right now, the speed of the water is still increasing. Remember, the speed of the water will increase up to a maximum and then decrease back down. So if I'm going to swim at 3:30, I'm going to be, I just want to know that it is ebbing, the water is lowering, it's still accelerating, but it'll top out. But it'll probably be accelerating the entire time I'm in the water because I'm probably not going to swim for that long. And we should also note that there's about 4.5 feet of water moving. Sorry, I put 5.5, but it's, oh no, it is 5.5. So that's a fair amount of water moving out. So what does that mean? Sorry, I have some notes here. One thing you should note is that ebbs are generally going to be stronger than floods. There is a lot of water moving out that is being pulled out of the Sacramento River and all of its tributaries and all of that, all the connected waterways to the bay. So generally speaking, ebbs are going to be stronger than floods. So you do want to be careful at areas like the opening and around, around the roundhouse here and around Farnsworth Gap. So if you are thinking about doing, sorry, I'm looking at my notes here. I mean, basically, you kind of want to consider what direction you're going to go in, right? If you wanted to go out and swim clockwise during this, well, you realize you're going to get a nice push along the buoy line, and then as you come and get pushed up here, but then you're going to really start having to fight against the current as you come back to the club. Now you can do it the opposite way. You'll get a nice push around here. You got to be careful around the opening because you could get sucked out. And as you come around Farnsworth Gap, you'll also get a struggle coming back. So it's really like, knowing what the tides are doing, knowing what the current is doing is going to kind of set you up to know what to expect as you're going out for your swim. Just so that we have an example for a flood, let's say I wanted to swim 4 p.m. Friday, March 5th. Again, I would look at the tide book, go to March 5th, try to figure out what block of time I'm coming towards, right, so 4 p.m. I can see low tide was at 11 a.m. and it's rising until 6. So it is currently flooding. Now, how strong is this flood? Well, not that strong. The max current is about 1.1 knots. Sounds pretty manageable. And there's about just under 4 feet of water moving. Again, as you're looking at this diagram, thinking about what to expect, what you're going to expect out there. Again, at the opening, you're going to have slightly unexpected things happen. I guess in this instance, what you could do is if you slam counterclockwise, you will be getting pushed around here, having to crab a little bit, come up here, get pushed around, and then catch the flood. Whoops, sorry. Catch the flood, hopefully as you round it out, get towards Farnsworth Gap, catch the flood to push you back. Now it would be much harder. If you wanted an uphill swim the entire way, I guess you would do it clockwise. Again, I think most people just swim along the buoy line, and I guess the thing to note is that during a flood, it's gonna be uphill and then downhill on the way back. And then during ebb, it's gonna be opposite, downhill and then uphill on the way back. There's just things to keep in mind, things to be aware of when you're planning your swim. Before I move on, I hope I'm not a swimmer, so I hope I captured those tips correctly. But is there any other swim experts here who might want to add anything?
Yeah.
Any nuances?
Eric, this is Andrew. You've caught the general outlines of what a swimmer would think about. There are occasionally times when, in particular, if you're looking at the example of the ebb that you had, when the area in front of, if you can go back to the ebb, the area in front of Farnsworth can be fairly tricky because there's a fair amount of water being pushed through Farnsworth, and it will drag swimmers who are not very strong. In fact, along that area of the pier is a place where occasionally we've had swimmers be overwhelmed by the amount of current that's flowing during an ebb. The way that people sometimes plan it is to swim a counterclockwise swim, and they get a ride toward the roundhouse, down toward Farnsworth, and then from Farnsworth to the flag, and from the flag to the piers, they stay as reasonably close to the shore, because the closer you are to the shore, the less strong the current is. If you're out in the middle, the current's going to be stronger. Okay, and looking at the flood picture now, places where we've seen difficulties, people have run into very strong floods pushing from Farnsworth Gap straight across toward the Thayer. And actually, that's a swim. Well, actually, yeah, that's a swim that is a lot of fun to do, because you're basically getting a free ride from the current. But to get there, you either have to swim against the flood by going to the flag and staying reasonably near the shore, or you need to swim out to the opening and swim along the edge of the aquatic pier to stay along the less strong part of the current, and then turning there and running from the goalposts in toward Thayer is, well, it's a lot of fun, but it takes full advantage of giving you the tide as well as whatever ride you get from your own strength. So those are just a couple of places where people have found that the tide is either very helpful or difficult to deal with.
Right.
But otherwise, those cove swims inside the cove can be a whole lot of fun.
Mm-hmm.
There are others that are more complicated, but I don't know that we need to go there in this presentation.
Yeah.
But you've covered the outlines of this really well. Thank you.
Great. Thank you for the added information and nuance. Yeah, like Andrew said, there's a much more advanced and complicated swims you can do. And again, as like I mentioned, there's a document that is forthcoming that we'll talk about those particular swims if you are so inclined and interested. Okay, moving on. So planning your row. I know not everybody here is a rower, but I think this information is can be useful to you if you ever plan on swimming one of our organized swims when those happen again. The general rule of thumb that we like to use when we plan our rows is to go uphill and then downhill. You want to row into the current on your way out when you're fresh. And then when you've gone as far as you think you want to go, turn around, catch the current to have it bring you back to the club. And this generally applies to rows that are along the shoreline and either towards one of the bridges, the Bay Bridge or the Golden Gate Bridge. Just to kind of reiterate something that Andrew just said, and this video will show, the current is stronger out in the channel than it is at the shore. A lot of that has to do with the depth. The depth of the bay in the channel, especially around the Golden Gate Bridge, is anywhere from 100 to 300 feet deep. So there's a lot of water moving out there. Whereas in the shore, like in the cove, I think the average is 12 feet or something, or the deepest is 12 feet. So this video will kind of show you the strength and direction of the current. As you can see, now it doesn't really show it right up against the shore where we are, but you can see the strength of the current is quite strong out in the channel. Oops, did I do that right? So that was flooding, now it's ebbing. And then you can see it turning around and flooding again. So it's kind of a nice visualization of what is happening. And the numbers you see are what's called depth soundings. So you can see depth of the bay here. It's actually kind of interesting to note. You can see, kind of like what I said about currents earlier, you can see that the currents, Alcatraz acts like a rock in a stream. The current flows around it, creating the kind of areas where there's no current at all behind it. And so it would be true in the opposite direction, on the opposite side when it's flooding. Anyway, I have a link to that video if you want to watch that, but I think it's just a nice visualization of what's happening in terms of the strength of the current. If you do plan on rowing cross-channel, one thing to note is that you are always going to be pretty much rowing perpendicular to the flow of the current. And so if you want to, let's say, row around Alcatraz during a flood, pointing your boat straight at Alcatraz would mean that the flood current would push you well clear of Alcatraz before you even got there. So if you wanted to take the most efficient line towards Alcatraz, you would point the nose of your boat into the current, and as you row, the current will kind of correct your trajectory and you'll end up over here rather than way over here. So that's something to keep in mind. one thing to note that's important for rowers is that tide events don't occur. Tide events occur at different times at different locations throughout the bay. So that graph I can so yeah, the graph and like the tide tables I showed you earlier were all for Alcatraz. But it's really important to note that if you are going to be rowing long distances, from the club to the Golden Gate Bridge, for example, the tide might be doing something very different by the time you get to the Golden Gate Bridge. So this is just an example from today. Max flood happened at the Golden Gate Bridge. Actually, let's do this opposite way. Max flood happened at 10:18 at Yerba Buena Island, but then it didn't. The flood continued to accelerate until 11 o'clock at Alcatraz, and it continued to flood until almost noon at the Golden Gate Bridge. So, you kind of want to understand what is the tide doing generally, right? It's flooding, and then try to understand, okay, what is the time picture I'm looking at in terms of what to expect when I get to my destination, either Golden Gate Bridge or the Bay Bridge. So let's say I'm planning a row for March 1st at 8:30 a.m. So I'm going to get to the club at 8:30. I'll open up the tide book and I'll look at currents at Alcatraz just to see what it's doing around the club. And I'll notice, well, slack was at 7:42, and it is flooding right now, and it will flood until 1:30. So that's basically, I'll be rowing into a flood pretty much the entire time. So I'm going to row towards the Golden Gate Bridge, right? I'm going to row into the current and then take advantage of the current as I turn around. Well, I want to make sure, I know that because of, slack is at 1:30, I have plenty of time to catch that flood. Now, if I look at the currents at San Francisco Bay entrance, slack is actually going to occur after I start rowing. So I might actually get a little bit of as I get closer to the bridge, it might be a pretty weak flood. But by the time I get there, get to the bridge, to the South Tower Bridge, it'll be, the flood will be quite strong, and I'll get a nice push all the way back to the club when I turn around. And again, rowers also have to be aware of eddy currents, but in our case, we can actually take advantage of them to help us, get to where we want to go. So the main current is flowing in this direction, and as it's hitting all these, going around all these little, not little, but all these things that stick out into the bay, all these piers, the water turns around and can help us, so that we're not rowing into the main part of the current the entire way. We can take advantage of these weaker currents and sometimes these back eddies that will occur. Which kind of leads to this other idea of, as rowers, we kind of talk about pier hopping. This is an example on the other side. So this is Pier 27, the cruise ship terminal. During a big ebb, you have huge currents. You have a huge current moving in this direction, but we can take advantage of all these, shadows, these current shadows that occur behind these piers and kind of poke in and take advantage of the weaker current as we make our way down and make our way east. And just so that we have and this is kind of an interesting example. Let's say I wanted to plan a row for March 9th at 7 a.m. Well, I notice slack is flooding, but it's going to flood until 8:30 a.m. And then it'll start turning around to me that, well, actually, what I can do, instead of rowing into a flood, I can take advantage of the flood, have it take me to the ferry building, and tie up, have breakfast, hang out, wait for the tide to turn around, and have the ebb push me back to the club. So that would be an example of taking advantage of, or rowing near slack and taking advantage of the currents rather than doing the uphill downhill kind of row. Okay. Before I go on, does anybody have any questions about planning a swim or planning a row? Because I'm going to talk about some exceptions and kind of weird stuff that you might encounter out there. Does anybody have any general questions so far? Cool. All right. Let's keep going. Exceptions and idiosyncrasies. So I kind of want to talk about, I used to have this this intuitive understanding of when the max current occurs. When we think of a pendulum, we kind of understand that a pendulum will reach its maximum speed at the bottom of its arc, right? And then it slows down and reaches zero, and then it kind of does that. And so when we think about it in the tides, which have a kind of pendulum-like motion or movement, we would think that the maximum current happens like in the middle of these 2 points. But that's actually not the case, at least not when we're talking about areas like the Bay, which have all these geographic features that restrict and manipulate the flow of the current. So just to look at this, I'm using a page from something called the Tide Log. It's another kind of privately published book that you can go out and buy if you want to. But as a graphical display of tide information, and they publish a version with tides and currents of San Francisco. So just to look at using the information here, we'll notice that slack does not coincide with high tide or low tide. So you can see high tide happened at 3:46, or sorry, low tide, this low tide happened at 3:46, but it's still continuing, there's still movement of water for many hours later. You can kind of see that these things don't really line up as you would intuitively expect. And same with the max current. We think the maximum current would coincide with the midpoint. So I've outlined, I've put dotted lines in the midpoint of the cycle. You can see that the maximum speed continues well after the midpoint of the cycle. And a lot of that has to do with, at the Golden Gate, it's a funnel, and you have this massive amount of water moving. So even though the tide is changing direction, the previous tide event, let's say we're going from ebb to a flood, even though technically the cycle is changing, there's still a ton of water moving against that flood, and so causing a kind of unexpected, or causing the timing of these events to be different than what you might intuitively expect. Now, obviously this chart, this all has it called out, so it's not something you have to calculate, but it is something you have to kind of remember, or just something you have to be aware of, that things might not be what you expect. It's basically what I have written here. Another thing that can kind of change your experience out on the water is wind and weather. After the tides, the wind is basically the other thing that kind of dictates what how easy or difficult your row or your swim is going to be. I think wind probably affects rowers a bit more, because as rowers, there's more of you outside of the water than there is in the water. So you are going to get blown around if the wind is really strong. A lot of times, if let's say you're rowing back from the ferry building on an ebb and you turn the corner around Pier 27 and the wind starts blowing, you might not feel the help of the ebb anymore, because the wind is blowing against you. It wants to turn the nose of your boat northward. Generally in the Bay, the wind blows from west to east. As a swimmer, the wind during an ebb, during an ebb, water is moving from east to west. The wind is moving from west to east, and that causes turbulence at the surface where they meet. So you get rough chop, that might affect your ability to breathe regularly. It might affect your ability to be able to sight and keep track of where you are and where you're going. So always check the weather forecast. Try to understand what the weather might be doing when you are out. And always be prepared because it does change very rapidly. I've definitely been out in a row where it's nice and sunny when I start, and I'll be miles away from the club, and all of a sudden it changes on me. So just understand what the forecast is, and that it could change at any minute. The other and kind of big environmental phenomenon that could change the experience of the tides and current are called freshets or freshets. I don't know how to pronounce that, but basically all the snow, or most of the snow that in the Sierra Nevada and the Trinity Alps, a lot of that melts into the Sacramento River basin, and all that flows out into San Francisco Bay. So during years of really heavy snowfall and really heavy snow melt, that can sometimes completely change the currents in the bay, either creating monster ebbs or negating floods entirely. That's something that generally happens, I think, late spring through early summer. So that's another thing just to be aware of. So basically, always double check the published predictions to confirm your assumptions. Then, even though you have all this knowledge, you checked the tide book, you've looked at the tide chart, you kind of made your plan, you kind of want to confirm those predictions, because everything published in those books are predictions. They're pretty accurate predictions, but they're still predictions nonetheless. When you're on the water, you want to observe how you're moving. Sight off of a building. What direction are you moving? Is it actually ebbing, or is it flooding? Am I in a microcurrent or am I not? And then don't be afraid to change your plans if it's not what you expect. Yeah, so that's reiterating what I just said. And lastly, so I'm going to share this presentation. I'll link it in the same post on groups, the groups.io member page. And I've got links to NOAA has a tutorial on tides and currents. Theirs are not going to be focused on the Bay at San Francisco Bay, but if you really want to dig into how the tides work, why they are the way they are, they have a great tutorial. And then if you want to find tide tables, they have that information there as well. So that's it. Does anybody have any questions? We have a few minutes left here.
Yeah. Hi, Eric. Thank you for the presentation.
Yes.
So what does the current speed not capture that the volume of water does in terms of information that you might want?
I mean, I think they both kind of affect your experience with water. I think, I'm trying to think of a good answer. I mean, for me, I've always been more aware of the speed as a rower. Maybe if other people have experiences as swimmers, like does the change in height matter more or affect you more than the speed of the water?
And it's generally the speed of the water.
Okay.
The only thing I can think of is that when you talked about the eddies, that would the volume of water affect the eddies more than the current or speed or are the same?
I don't know that I have enough like observational experience with that.
I guess
Thank
I'm
you,
just
Mr.
trying to
Stevens.
think of when I see the height of the water, or the volume of the water, should that tell me something that I don't get when I look at the currents?
I mean, I think volume is still something that should be taken into consideration. Because you are theoretically swimming against a larger mass of water.
If you are looking at the tide tables and you look at a differential between the high tide and low tide that's very large, there's a lot of water moving, and that's what's going to affect you the most. If you find that there's a difference between the high and the low, or between a low and a high that's fairly small, then you're not going to have much effect from the current. And it's the difference between either the height and the low, or the low and the high, is going to be an indicator for you of how much water is moving, and that will turn itself into being the current that you're going to have to deal with at any given time. Does that make sense?
Mhm. Does anyone else have any other questions? All right. Well, that was it. Hopefully that was helpful.
Thank you.
Yeah,
Nice job, Eric.
thanks.
Need a little more practice reading the book.
Yeah,
Other than that,
I will share the presentation as well as the recording once I find out where it gets saved. So you can definitely check back in and refer to both of those things if you need to. Oh, the last thing I wanted to say, your experience in the water is going to inform like how this information is going to be useful, because there are a lot of variations and a lot of things you just don't know until you get out there. So yeah, all this information is definitely useful. It gives you the first step in understanding how you're going to need to react when you get into the water. All right. Right on time.
Great job, Eric.
Thanks.
I really